All right, last one. Let's sketch the graph of the cosecant of x. And again, much like how when we graphed cotangent, this will be very similar. Cosecant isn't that very different a function from cotangent. Nope, cosecant is not that very different from secant. It's 1 over sine instead of 1 over cosine. So I'll encourage you to go through this page on your own, then come back and watch this video, maybe at like 2x speed or something. So let's sketch the graph of sine of x, and that'll be our starting point. Cosecant only involves sine, so I probably only need to care about sine. So what does sine look like? Its graph looks something like choop, choop. Something like that. Where is it positive? Where is it negative? Well, it's positive all the way from 0 to pi, negative all the way from pi to 2 pi. So cosecant, 1 over a positive is positive, 1 over a negative is negative. Cosecant is 0 when the numerator is 0. When does that happen? So cosecant will have no x-intercept. 0 is not in the range of cosecant, just like secant. 0 is not in the range of secant. Cosecant has a vertical asymptote whenever the denominator is 0. Well, when is sine of x 0? Well, by looking above, it looks like sine of x is 0 at 0, pi, 2 pi. So there will be a vertical asymptote at x equal to 0, x equal to pi, x equal to 2 pi. Vertical asymptote at x equal to 0, vertical asymptote at x equal to pi, vertical asymptote at x equal to 2 pi. And the reason I drew the first and last in the same color, well, notice that's at x equal to 0. This is exactly 2 pi to the right from x equal to 0. So this is, in some sense, like the same vertical asymptote. It's not the same vertical asymptote, but it kind of comes from the same fact. Right, an angle of 2 pi is kind of the same angle as 0. It's not really the same angle, but it results in the same point on the unit circle. Just like caring about when is secant 1, we'll care about when is cosecant 1, because those will give those valleys and peaks for cosecant. So when is cosecant equal to 1? Well, we need to solve that equation. That is, we need to solve 1 over sine x equals 1. So I guess that means we need to solve 1 equals sine of x. And, well, by looking at this, it looks like sine of x is 1 at x equal to pi over 2. So when x is pi over 2, sine of x is 1. So there's this point at pi over 2, comma 1. When is sine of x equal to negative? When is 1 over sine of x equal to negative? Well, again, that's just when sine of x is equal to negative 1. And by looking up here, that happens at 3 pi over 2. There's 3 pi over 2. Go down 1. 3 pi over 2, comma, negative 1. All right, so this is like the smallest so 1 is the biggest value that is on the graph of sine, so 1 should be the smallest positive value that's on the graph of cosecant. So from here I just need to go back to get to the vertical asymptote, go forward to get to that vertical asymptote. Same thing here. And then that's the graph of secant over 1 full period. Now just repeat. So take this, shift it to the right by 2 pi. Take this line, shift it to the right by 2 pi. Take this bowl, shift it right by 2 pi. Take this mountain, shift it right by 2 pi. And shift left by 2 pi. Nice. So we have a graph let's check the same facts as before. It looks like this function is odd, which it should be, right? Sine is odd. 1 over an odd function is still odd. Secant up here. Let's see, is that even? So how do I do this? So what would you want to do? You would want to check if it's even, you would imagine like blocking off all of this and then seeing if you just reflected over the x-axis, would you get that back? And indeed you would. Let's erase that. This is even. How about intervals of increase, decrease? So starting from 0 at that vertical asymptote all the way to pi over 2, it seems to be decreasing. And then it switches to increasing. Then it's increasing from pi over 2 to pi. From pi to 3 pi over 2, it appears to also be increasing. At 3 pi over 2, it switches to decreasing. Until it makes it to that vertical asymptote at x equal to 2 pi. And you could keep on going. So you can figure out intervals of increase and decrease by looking at pictures. How about domain and range? So let's figure out what's not in the domain. So I see a vertical asymptote at 0. 0 is not in the domain. Pi is not in the domain. 2 pi is not in the domain. 3 pi is not in the domain. 4 pi is not in the domain. So the domain seems to be all numbers, but multiples of pi. Comparing that with secant, the domain of secant was everything except for odd multiples of pi over 2. So things like pi over 2 is bad, 3 pi over 2 is bad, 5 pi over 2. So here it's things that are just multiples of pi. The range. Well, you answer this by seeing what y values is he on the graph. Well, any y value less than -1, yeah, that's totally in the graph. Y equals -1, yeah, that's on the graph. Things between -1 and 1, nope, those aren't on the graph, but everything else is. So the range is -infinity to -1, together with 1 to infinity. Cool. So this was a short video, and I talked a little bit fast, but that was because, well, it's pretty similar to what we just did. Cool. So I'll stop here. Check out the homework for the section. I'll see you in class.